But yeah, so my name is Joris Strumpflohner. I'm from Italy. We just talked about it, even though my name is pretty German. But I'm living in a very northern part of Italy where we speak like German and Italian. So that's why I'm also Google Developer Expert since like quite a long time now. And occasionally I also publish online courses on Egghead and also on the NX YouTube channel. So if you happen to chime in there, you might have seen me like put out some content there. Now, this is actually a good line, and this is kind of like, this is from Victor Safkin, he's the co-founder and CTO of NX. And this is kind of like the idea of what NX wants to provide at a very high level. I know this can kind of be very salesy, right? So, but like our mission actually is to make sure we kind of reduce the overhead on teams, right? So to reduce orchestration costs, try to help with communication issues between teams inside a bigger monorepo most of the times, right? And to basically just increase the throughput, because in the end of the day, that's what like companies want. They want to be efficient even though they are scaling up. So at some point, like you run into like smaller teams, there's a lot of communication overhead going on, and so we try to kind of push that forward and help with those issues. And monorepos can be one solution for that, right? So they can be great, right? Because they can kind of help with some of these issues, like reducing the communication overhead, also facilitating collaboration between teams, because now you just have one repo, everyone kind of sees what the other team is up to, versus in different repos where you don't even know where they host the code. You may be using it, but you don't even know where the code is actually situated. And again, they can help you ship faster. Now, you can hear that I say like can help, they can be cool, because there is actually some gotcha. Like it is not for free, like everything, right? Like whenever you opt in for a specific technology, there are gotchas potentially. And so they don't come for free for sure. Very often what we see when we collaborate with companies is they can be initially that new shiny toy, because you have kind of like maybe complex, kind of bit messed up situation of different repos, kind of hard to collaborate. And so I was like, hey, let's go with a monorepo. It's gonna solve all of our issues, right? And so it can help, but there's some pain I usually say that you don't see just yet that's coming up. Maybe instead of pain, let's call it challenges, because I have a nicer word. But there's challenges obviously connected with the monorepo, and that's where kind of we try to come in and help overcome some of them, or at least like mitigate them, such that like you can still benefit from the advantages, but not have too much of the drawbacks of a monorepo. And so I kind of try to group them. Like there's a lot of like pros and cons. I try to group them into 3 different stages where someone might be in when moving to a monorepo, which can be like more from the consolidation stage, where you either start a new monorepo or you migrate from an existing reality of multiple repos, etc. So you try to consolidate into a single monorepo. Or multiple monorepos, it's also possible, obviously. Then you go into the phase of enhancing the monorepo, so trying to actually structure it, make sure it's maintainable, keeping the tooling up to date, etc. And then finally, obviously, there's the scaling aspect to it, because you might have different teams, so you get more people onboarded, but there's also the issue of CI, right? Like we all know, like once you have a monorepo, CI is something you need to look at, and you shouldn't ignore, because otherwise it's gonna be tough. And so NX tries to cover the whole spectrum. So we try to provide solutions for the whole spectrum, basically from, as I mentioned in the title of the talk, from the local development up to CI, which covers these 3 phases roughly. And so these are some of the solutions. I'm just like throwing them in here, and they're not even all of them, right? So it's just like some of the more prominent one that we offer, and some of them we're going to quickly look at today. But yeah, it ranges through different phases, and some of them actually overlap, right? They are kind of in between of enhancing your monorepo, but also helping with scaling and helping with consolidating, but at the same time enhancing your monorepo. Obviously, the lines are blurry here. This is more like for kind of showcasing it in a better way. So let's start with the NX architecture. So what does NX kind of look like at the very high bird's eye view, from a bird's eye view perspective? So generally, we have an NX core. Then there's plugins you might have heard, which is actually nothing else, which are like npm packages that plug into NX. And then there's the CI part, which is more like the continuous integration, scaling, that type of part that NX kind of covers a lot. And then we have editor support. That's actually, unfortunately, often not talked about as much, but it can provide really huge value. in a monorepo. So you can enhance basically day-to-day work with a monorepo by providing integrations in VS Code, in IntelliJ, etc. So you can make things a bit smoother. So it's definitely worth bringing up. And so from a like if you want to have boxes of how they arrange, you have the core that directly can integrate with the CI, and the plugins can stick on top. So you don't have to use them, as you don't have to use the CI features, right? You can just stick with core, go with that, or you can add plugins, or you can just add CI features. So that's intentional. So we want to make it such that you can migrate in easily, right? So you can start with a small piece of it, and then over time add more and more stuff to it. And we're gonna have a look at some of these things. So core is tech agnostic. So it is written right now, most of it still in TypeScript, some of it in Rust, but over the course of this end of this year, next year, most of the core functionality will be in Rust. So we implemented some of the core features and rewrote them in Rust just to see how much we would gain in terms of speed. And it actually matters. So core wants to be fast. It wants to obviously have the core functionality offered, and it wants to be extensible. But the fast and speed is a very crucial point there, a crucial aspect, because we want to introduce as little overhead as possible. So you add NX to your monorepo because you want the monorepo to be faster, more manageable. So we want to have our overhead as little as possible. And also the tech agnostic part is actually pretty interesting here, because NX can work outside of JavaScript. And Rust will help with that even more, right? So at some point you don't even have to have node modules if you don't want to, if you work with, say, Java, .NET, and other technologies, Go, etc. So what are some of the core features that NX Core offers? It's basically the whole functionality is around task running, right? So you can run tasks in parallel, just those that were touched, affected, etc. It is able to identify task dependencies, and you can also define them. So you can say if you build a specific aspect of your monorepo, it needs to build its dependencies first, or it needs to run certain aspects first. So those are things that in a monorepo are crucial, because you don't want to hand code them, especially because as your structure changes, which it does quite a lot in big corporations, you don't want to touch the configuration always again, right? So it should just work automatically. So it has this notion of understanding task dependencies, which is often also called task pipelines. It comes with local caching. Again, that's for speeding up and not having to compute things that simply don't have to be recomputed because they are already done. And it comes with a whole set of workspace analysis. So there's actually an NX daemon running in the background to analyze your workspace, the structure of it, and all this data is actually fed into how tasks are run, how they are scheduled, which one are run in parallel, which are not, etc. So a lot of these things go into the other features from that workspace analysis. And you can also look at that, right? You can run NX graph, for instance, and show the graph actually visually, which can also help sometimes with inspecting and pinpointing certain areas of your monorepo. And then there's some extensibility points for additional features that are usually then provided by the plugins. So that's for code generation and also for automated migrations, which is automatically updating your tooling, basically. So one of the core parts there that we want to focus as well is minimalism, in the sense that core should be super lightweight. You can actually just run NX init on an existing monorepo, like let's say an NPM workspace. Actually, even on a single repo, you can run NX init. It will understand what type of workspace it is and propose how to configure itself, basically. And what that most of the time means is installing the NX package. And here we are talking obviously from a JavaScript perspective, a JavaScript project. So it installs the NX npm package and it creates an NX JSON and configures that based on some questions that are being asked during that NX init. So it should be as minimal as that, and that's it. With that, you already get parallelization. You can run tasks in parallel, as you can see in the screenshot below. And you get caching. If you define that build is cached, you get it out of the box. It already works with that. And most importantly also, when you run these tasks, they just run the existing scripts that you already have. So if you run NX init on an existing npm workspace, NX will just hook itself on top of the scripts. That's it. So it runs existing scripts and caches them. And that is an important point because you want to make this easy, right? So you don't want to have to make you don't want to force people to do a lot of changes just for being able to add NX to it. And so for a single repo, you could do this, but obviously the gain there is not quite huge, right? Even though NX brings some benefit into it, the real benefit you get from adding this onto an existing repo. And why? Well, you can run existing scripts, as mentioned, so no overhead on that end, but you get task pipelines. You can configure that, like builds which tasks depends on each other, kind of what I touched a little bit before. And you get also local caching and potential remote caching with that to speed up things, right? So you can already kind of see some benefits without actually a lot of changes that you make. The main part with core though is you manage everything, right? Again, as I said, like we just hook onto existing scripts, so you need to make sure that these scripts work. And they probably do because you have been using them before, right? But you need to kind of manage those, and X kind of stays out of the way at that level, which can be perfect, right? And it can be actually really perfect for onboarding, for moving from an existing reality to an X. And that's one of the main reasons why we try to make this so easy. Now, we kind of continue to try to think about like how can we do better without being too invasive, right? So what can we do better? And one part that comes here into play is NX plugins. And this is the second part of the architecture, as I mentioned initially. So we have the core functionality, now we have the plugins. And the plugins are basically more technology specific, while core is technology independent. Plugins are more technology specific. So you will find a plugin for Vite, you will find a plugin for React, for module federation, etc. So these plugins cover a single responsibility, and their goal is to try to help you, basically, to try to help you configure tooling, configure caching, so you can just kind of not worry about those aspects and more focus on actually building functionalities and managing those types of things. Now, if you have been using an X in the past, and this is more for people that may have used it in the past, went back and forth on it, plugins have been a bit more involved, a bit more complex in the past. And so we are currently in the process of making them even more lightweight, even better. And so here, for instance, you see what a plugin configuration looks like. And some of them still look like this, where you have to have a project JSON, for instance, which is actually equivalent as a package JSON, where you define your targets to run, but you provide a bit more data to an X, right? So this is like, if you think about it, like a project JSON script on steroids. So here you see, for instance, a concept of an executor, which is nothing else than the build function in that NX Vite npm package that is being invoked with the properties that you pass in. So it's more configuration oriented. And clearly that also means it's more opinionated, right? So you can do only what is allowed here via these inputs and outputs that are being provided to these scripts here, these executors, how we call them, to run, for instance, the build using Vite in this specific project here. Now, for Greenfield project, this is actually pretty nice. And we have a lot of huge corporations, huge enterprise that use this approach because it kind of limits you a bit in the ability of messing things up, if you want, right? So it is within that box, and you can just move within that box, but it has a lot of advantage in that, like, you can tune that box as much as you want, and then this is how things are being done. So the variability is a bit limited, which for enterprise is actually pretty good. For open source projects, less so, right? People don't like as much being restrained in some of these features. Another problem that we found, though, is for migrating existing projects, it's also not as ideal. And it's actually pretty apparent, right? Because like if you have a package JSON script, now if you want to leverage plugins, you need to kind of somehow migrate to this structure, which in some cases can be pretty straightforward. We actually even created some automated migrations to do that for you, like during the NX init phase. But in some other configurations where you have done some more customization, this might be harder. And the main reason is why, because the plugin structure looked mostly like this, right? So you have some options that are being passed into this box, and this box, like in this case, the NX Vite plugin, for instance, manages everything, including talking to the lower level Vite CLI internally. And then it produces outputs. And so what we wanted is, like, we wanted to have that minimalism of the NX init, which the NX core provides, but enhanced with plugins. So as I mentioned initially, the plugins right now, you can just plug them on top. And so that was the goal why we did some of the rewrite of the plugins and some of the optimizations of the newer models of the plugins. And this is kind of like the metaphor that we've been using along the way. So what if these plugins are more like VS Code extensions? You don't have to use them, right? But here, for instance, this is a screenshot from the Playwright VS Code extension. It's actually pretty neat if you have them, right? They just make things easier to work with. Like you have these action buttons, you have a test explorer that filters out just the tests you're interested in. So they can make your life easier when working in a repo here with Playwright. And that's kind of the notion that we wanted to have. So you don't have to use them, but if you use them, it's actually smoother to work with the NX monorepo. And so enhance, don't interfere, right? So just plug things on top. And so what we did is we moved from this pattern to this pattern, where we have the plugin at the top that manages some of the logic internally, which still might be required, because if you want to use Vite in a monorepo, you might have to fine tune some of the options. And we know them because we keep using these projects and we keep talking to large corporations about it. And so the plugin can encapsulate some of that knowledge, so you don't have to figure that out. And then it just invokes the VCLI underneath with some of the commands that we fine-tuned here and produce the artifacts. And now the crystal here is therefore because we called these new projects, these new plugin mechanisms Project Crystal. So if you come across that in an NX ecosystem, that's why, because they are more transparent, right, in how they actually work without being just a black box. And the best thing from those, in my opinion, is that they now rely on the actual underlying config. So if you have a Vite plugin, it will read the Vite config and you tune the Vite config and the plugin will automatically sync with the changes you make in here. So you don't have a duplicated configuration like in a project JSON and in the Vite config, but actually the plugin leans on top of it as it should be. Which also means if you drop a plugin into a project that has a Vite config and you drop this plugin in, it will automatically know how to behave. You don't have to do any other configuration. And so with that, we actually achieve this notion of like drop in as VS Code, right? You drop in extension, it automatically enhances the workspace without you having to do a lot of different like configurations and changes and whatnot. And with that, these plugins can also then infer some of the targets that you can rerun. So for instance, if you have a Vite config and you drop the NX plugin, you don't even have to have the targets in your package JSON if you don't want to, or in your project JSON, because NX Vite knows, well, Vite allows you to run a dev server build and a preview task, and it knows how these need to be configured. For instance, that build needs to be cacheable and where the location of that output artifacts are, because it has access to the Vite config. And so that makes things really, really nice to work with. Here, for instance, you see a screenshot from a React app with Vite where the project JSON is empty. You could actually even drop this one and have it as just a package JSON, or in the future potentially drop it completely, because once you have the plugin in, it would know that it has these different tasks that it can run and auto-configure them for you. The view that you see here on the side is the famous editor extension that I mentioned before. Now you don't have to have it, like this is NX Console, which is our editor extension for VS Code and Web Store. You don't have to have it. You can also just run a command. It will open up in the browser, the same exact view, but it is nice to have, right? So you have it right inside your view of the project. You see what tasks you can run. You can actually trigger them directly. But if you open one of these up, you can also see what happens inside and what they actually run, what the build, for instance, here runs. You see it is cacheable. Underneath the command that will be triggered is just Vite build. That's it. You can also see some options that are being configured. So this, for instance, here, it sets already the Vite CLI to run in this current working directory, which is the application itself. So the Vite config is picked up properly. It is these things basically that are being handled by the plugin. And down here, you see also it automatically configures the caching inputs and outputs. So it knows where the output path will be because it read the Vite config. And so it can automatically cache that one. If you change that or override that in your Vite config, this one will update automatically. So you don't have to do anything on the next side of things. And so this is kind of like a bit the mental model of these new Crystal plugins, as we call them. And it turns out these are amazing actually for adopting and importing existing projects as well. Because as I mentioned before, once you kind of have the configuration file and you add the plugin on top of it that understands this configuration file, like Vite, for instance, it will run automatically, right? So it will work. And so we added actually a couple months ago a new command that is NX import, which allows you to pull in an existing project into your monorepo, into your NX monorepo. And it is actually a variation of pulling in the source, running NX init on top, suggesting some of the plugins that might apply to this project, so you can select them or not, and then it auto-configures that project. And so the idea is to make the whole migration really, really smooth. So this is actually a registration of a video where I take a Java project, for instance. This is with Spring Boot, uses a Gradle configuration. So meaning here in this Spring project, you can run Gradle build, obviously, Gradle test. And now we're going to import this into an NX repo. So this is an NX workspace, an NX monorepo with React applications, I think even an Angular app, a couple libraries. And so we're running NX import, pointing to the source. We could also point to a remote Git repository. And it will just ask you a bunch of questions. So which branch do you want to import? Where do you want to import it into your project? And it suggests some plugins and then installs it. So you can see now here, the project is in. If we run git log, it also pulls in the actual git history. So that's actually a huge win because you don't lose that git history. You can actually still have that. You can run the project and you see it will be automatically detected because there is the Gradle plugin that detects the Gradle configuration, so the build Gradle. In fact, if you open it up here, you see that NX console product view where it detects properly the tasks. It detects they are cacheable, and underneath here you can see it just runs the Gradle build command as we did manually before. It also configures the caching input and outputs because it knows where those will be. And so you can run the build just as you would do for a front-end project, or even run it across the board, right? Run many-build test, and it will run it for Java projects, JavaScript projects, React projects, etc. in the same monorepo. And obviously you get caching, etc. As well. And so this is kind of like the idea that we have for these plugins. And clearly it integrates into the project graph also. And so this is the consolidation phase, right? This is how some of the things that we did this year, last year, to pull things in and make things easy. For enhancing, that's the next step. So once you have the monorepo running, up and running and working, you will keep inevitably add new projects into the monorepo, right? So it will grow over time. And at some point you will end up, hopefully with not something like this, but you will end up with a situation where you need to make sure that there are some pillars in place to make sure to group things and make things maintainable. And this is where some mechanisms come in to control the structure of the monorepo. So how can you do that? There's different approaches. Obviously, standardization helps a lot in big enterprises. So make sure this is how a React app should look like. This is how React library or TypeScript library should look like, etc. So having these standards, but standards can only work really well, as we've seen in large corporations, when you automate stuff. And so we have plugins that can provide code generation facilities. And so they can generate the React library for you, but the more important part is you can create your own. Right, so there's this extending NX documentation section on our website, which teaches you how you can actually create your own generators or even plugins, and even extend from existing ones and just add your features on top. And the most of the enterprises that we work with have done this quite extensively, especially initially, because then you have a really smooth process actually to set up new libraries and make sure these are within the standards that you define within your organization. But obviously, once you are able to create these projects, etc. Now, who reviews them? This is another feature that we added lately, which is the notion of ownership. Because as you start structuring your repo, ideally they're structured around domain areas, right? So you have the orders team, shop team, like this is a fictitious shop, online shop application, like Amazon, whatever, right? And you can kind of link them together. But you have these different team members, and so if something in orders changes, well, someone from the orders team should at least probably look at it. And there is obviously the notion of code owners. The thing with code owners is that it is kind of like suboptimal. It kind of works, but it involves more effort because it's file-based, and you need to keep it updated as you keep changing your monorepo structure. So you need to update the file paths, etc. So what we did recently is we introduced what we call a power pack. These are features specifically dedicated for enterprises, because usually in an open source product, it doesn't really matter. You can create that on your own, can keep those code owners file in sync. For larger enterprise, that has been a big ask. And so what you can do with that is write the owner structure in NX.json, for instance, where you can either have file globs, or you can actually use tags that you assign to the projects, which are also used for other purposes. And then say whenever there's the tag scope orders, well, the orders team or the name of the orders team, like the different members, should have a look at that and review that. And then we have a command on top that is nxsync, which synchronizes this configuration to an actual code owners file automatically, right? And so that code owners file obviously then is written depending on whether you choose GitHub or GitLab or Bitbucket, because there's some variations on those different ones. And so this allows you to do this translation where the sync process then writes the full paths automatically for you. And then we are in between, like enhancing and scaling. Again, I mentioned initially a bit like there's some blurring lines there, because another point in the whole enhancing but also scaling phase is you need to have boundaries and ownership to enhance your monorepo, but at the same time that also allows you to scale it. As you add more people, if you have these rules in place, then it will also help you scale more effortlessly and make sure you are succeeding even as your Monorepo starts growing. And so part of that is verifying ownership, but also verifying these boundaries that we mentioned initially. And we kind of use the term conformance for that, right? So we kind of wrapped those two aspects and potentially multiple ones coming in the future under the conformance aspect and create another package out of that, which allows you to basically define rules. So the whole idea is to have, you could actually make the analogy with linting rules, but that work across technology stacks. So they would work also in a Java project, in a Go project, etc. So they're more high level, but feature-wise, they're pretty similar. And so for ensuring owners, for instance, we come already with a pre-made rule where you define the rule simply in your Annex JSON in that conformance property, and you define which projects are included, or the other way around, you just blacklist some of the projects that should not be included. And what it does basically is just you can run Annex conformance, and if, for instance, some of the projects that are new don't have an owner assigned, well, it would run and fail. And this is important because if people start creating with these generators new projects in your workspace, you want to make sure that they are properly set up. And ideally, your generators are customized and they already set up the ownership automatically or ask for that. But otherwise, you can have such rules that make sure on CI they will fail and therefore will block the merge of the PR. Next thing is the enforcing of the boundaries, right? Kind of similar as I just mentioned, but instead of just verifying the ownership, when we have these boundaries established, which is highly recommended, we also want to make sure that these stay in place, right? So these lines here that go across boundaries need to be verified and explicitly approved, such that you don't have like a mess where some part of the orders down here, because they created like a cool UI dialog, is being referenced by the shop part, right? Maybe that's legit, but these should be intentional. And so for that, we have another rule that's called enforce product boundaries, where you can define basically a starting tag, a starting project, and an end tag, and define which combinations are allowed and which are not. So here, for instance, I have a couple of examples where I say whatever is like source tag type backend should not be able to depend directly on type frontend projects, right? So usually that's not the case, but there could be some overlap, even just on configuration files. They shouldn't collaborate with each other, right? There should be a limit between those. And similarly down here, I've specified where a project of type a feature library that's encompassing more high-level feature library should only be depending on other feature libraries and lower-level libraries such as utility libraries, data access libraries, etc. A utility library should not be able to directly extend from a feature library, for instance. That's the main goal that you have with these. And you can create your own, right? The extensibility is always very high on our list. So you can actually create and implement such a rule which implements your specific feature logic, where you have access to the product graph and the options of the rule itself that you give. And then you can iterate this product graph and make sure these rules are being respected, and then return corresponding reporting result. And this is how you run them on CI. All right, then we come to the last part, which is the elephant in the room, which is scaling CI. Because clearly, once you have a monorepo in place, this will be the inevitable situation which you will end up, right? So you add more projects and they just sum up, and meaning your CI time will go up. And so the whole point of like tooling like an X is to be able to try to keep this as low as possible. I don't want to say flatten the curve because we're kind of burned by that term, but that's kind of the idea, right? To keep it as low as possible via different mechanisms. Our current flagship product there is NX Cloud, which is one part that attaches into NX and some of the features of NX to make sure CI is as fast as it can be with a monorepo structure. And so these are some of the features. There's a docs section here that goes much more into the more details. I'm just giving you a super high level overview here of some of the features that we implement, and some of them where we have seen really good success when we work with companies. One of them is obviously remote caching, which does nothing else actually than taking your local cache, which is on every NX instance, and distribute that. So it just synchronizes that with a central location and broadcasts it to other machines. Most prominently the CI part, obviously, because this is where it's most used, right? You can even play it down to your developer machines, so their builds are faster as well locally. But usually this is where you're interested in on the CI part. You want your PRs to be fast and merge fast without wasting too much time. We've recently also introduced a power pack for that for self-hosted cache storage. So rather than just having the remote cache on NX Cloud, you could actually attach it to your S3 to your network drive. We recently also added like Google Cloud and Azure. So these are also options. They just cover the remote part, the remote caching part though. NX Cloud actually shines if you combine it with also task distribution. So usually these things built on top. In fact, I often call them almost like layers of speed, because you have the good parallelization of NX and like fast task running, and then you add caching on top, you add remote caching on top, you add distribution on top, and you add task splitting on top. Like these are layers that you can gradually add on top to speed up things even more. So task distribution is a feature which basically allows you to parallelize on CI. Like locally, if you run tasks, we already run them in parallel. But at some point on CI, even if you have caching, you might run into a situation where the cache is either not kind of pre-warmed, right? So it's empty, or you run into a situation where you change a library that is kind of like a central part of your monorepo, and you still end up building everything. And so those worst case builds then take like an eternity. And if that happens often, that might be a huge degradation, obviously, to your speed. And so everyone at some point starts to parallelize. And you can do that manually. Like here, for instance, you just say machine 1 does just the builds, machine 2 does just like end-to-end tests, etc. And then machine 3 does the rest of the thing. The problem is this is static though. Like first of all, you need to configure that. If you assign basically to which machine does what. And then if your monorepo changes, maybe at some point these builds here or the tests are becoming much slower, much longer. And the time of your CI is actually the slowest one, right? Like this is how long it will take, because these one, even though they finish earlier, they are just waiting. So this is like this part in between here is a waste of time basically. And so we wanted to solve that solution. We should solve that problem basically. And what we wanted to do is like not have a model where you assign machines, but rather where you say, I have 4 machines and I just want them to be used in the best possible way and take tasks as they have time. So be most efficient possible. And so what happens is you have all these tasks. And now we use the NX project graph that I've mentioned earlier to understand how these tasks play together. So which task needs to run first, because maybe another task is dependent on it. So it needs to run first, it needs to be scheduled first. And so we use that notion and that idea to make sure we balance and distribute them in the best optimal way. And so what happens is these are being distributed across these agents completely automatically. Like there's no ordering given by us, but rather the agents figure that out based on the dependencies of the tasks. And the cool thing is also like if you at some point see 3 agents are not enough, you can add another one, and it will just then sparse out over 4 agents, right? And you can add 5, etc., depending on where your limit is the best optimal way to have these things working. And here you can also see if there are dependencies between those, things are being replayed. So this is being built first because this one depends on the build. Like this is an end-to-end test that depends on the build of the product. So this is being scheduled first because there is this dependency. And then it is automatically replayed via the remote caching to this machine, which can then just pick it up at almost 0 cost, run the end-to-end tests on top. Now, one issue though that you have seen is these end-to-end tests, they were super long. And so what we added additionally to as a feature is the ability to automatically split these end-to-end tests at the file level. And this is what happened here in this animation. Rather than having a single block, which is hard to distribute because it will always be that single block, we added the feature to allow you to kind of split this up in a fine-grained way. And now we can actually distribute it much better, right? And so you can see it's much more uniformly, and therefore you can kind of speed up the overall timing. Similarly, also if something fails here, like one of these tests, we can detect such a flakiness, automatically reschedule it on another agent. That's why, just to be sure, nothing is like specific to this machine that kind of made it fail. Rerun it again, and then maybe it's already passing. You as a developer would never notice. It just keeps going, and that's it. And so the important part of this distribution model is that it kind of changes what you usually or traditionally have been doing on CI, because traditionally this is the metaphor, right? So you have all this work to be done is pre-allocated to all these people, that's it. But if one of them gets sick, that work will just stay there. And similarly, if one of the machines on CI will fail because node modules cannot be installed, the entire CI run will fail. Now on the NX Cloud and the NX agents, how we call them, model for distribution, follows more this pattern where you have a big table almost with a bunch of different things to be done, like tasks, and the agents just pick them as they have available time. So once they run idle, they pick up tasks and process them. And so what happens if one agent fails during the bootstrapping time? Well, you will just have a slightly worse scenario where you just have like 2 agents instead of 3, but your CI doesn't fail. It just takes a bit longer. So it's more robust, and you can distribute much better. If someone for some reason takes longer, others will just pick the work up, and that's kind of it. So that's kind of the idea that we follow there. How do you enable that? It's actually pretty straightforward, right? So you have this single line, which enables distribution. In particular, here you say, I want to have 3 machines on CI running of this type of machine, which this is almost like a Docker image. So there's like NX Cloud workflow templates that you can customize. In one of the upcoming versions, you can even say auto. So you can say auto here, and then on this NX Cloud dashboard, you can say, I want to basically tune that the CI can take only so much time, but I want to maximize, to maximally only use 10 agents or something in the worst case scenarios. And so based on your PR size, based on how long the task took in the past, things are being scaled up or down to either respect your timing or your maximum resources that you want to allocate. So it's kind of like a trade-off that we try to make to optimize time with money, right, and resource users, which translates to money. And so you run this line, and then once you run the commands via NX Cloud will pick those up, intercept them, send them to NX agents, and everything in the end will be replayed back into your CI machine, such that the task that run after this one here can just use the resource as if they were just built on this machine. So that means like if you have reporting like to be sent to some external agents or something, like that can happen without any issues. All right. And that's kind of ending the whole part. I just wanted to make sure, like, or to kind of talk a bit about what are the advantages, like maybe compared to other tooling. So one of the things is like we try to cover, as I mentioned, the whole spectrum. Right? So we don't want to just optimize the local development, but actually also help you on CI. Now you can start with one thing, but there's always like the certainty, like if you run into trouble, there is a solution potentially waiting that you can apply. All of these features, we didn't even touch all of them. Like we didn't talk a lot about migrate and not even release, which is for release management, versioning, and changelog of packages, and in the future also applications. So these things can be applied individually to a workspace, so you can gradually enhance it as you run into trouble. We have a lot of attention for DX. It's very high on our list. If that is like, for instance, to have, for instance, editor extensions, but also in the plugins that we create. A lot of them we dog food into our own projects to make sure they run properly, and with the clients that we have, we know what the problems are basically and feed them back into some of these extensions. Extensibility is very, very important. We see, as I mentioned initially, a lot of the corporations, enterprise that use NX start extending it quite heavily, actually, because you can simply tailor it to your own needs, right? And so you can basically automate and code some of the standards and processes that you want to have and embed them directly into the tooling. We have a really good and huge community. We have a Discord channel. You can find all the links in here. We have the Discord channel. There's a very active community. We have NX champions, which are similar to the Microsoft Most Valuable Professional program, for instance, that are working with a lot of clients as well, and they are very close to the core team. So there's a constant exchange going on. We have a lot of resources for learning and diving deeper. So we really care about that, me personally as well, and to kind of have video content, docs, blog articles, conference talks where we dive into these topics. And we're also always happy to hear problems such that we can actually translate them to good resources. But the big advantage probably is like definitely that we work with a lot of companies. We have come from the consultancy business, and we still have like very close connection to a lot of enterprises. We actually have an enterprise program where we have dedicated people that keep talking to companies to make sure things work smoothly. And we see really good results from some of those. So you can go to this page, but also to our customers page to see which clients we have. And there are some case studies as well that dive deeper into some concepts, which may be less interesting for like developers, but very interesting to understand like the impact that you could potentially get out of it. Cool. I think I was a bit slower than I expected, but this is how you can get in contact with us over our official channels. And obviously always feel free to, just reach out to me, and we can dive into some specific topics then.